Okay, so today we're going to look at lesson 1 with quadratic equations. The first lesson looks at a review of factoring. So factoring basically is to polynomials what division is to numbers. Multiply two numbers together to get a product, and then you can take that product and divide it by one of those factors to get back to the original. So factoring involves writing a sum or difference of monomials as a product of polynomials. So we're going to review some of the techniques that we learned last year. So the first technique that we learned last year was what we called factoring by inspection. So those were the salt and pepper, the sum and product charts. So something like x squared minus 8x plus 12, the sum was the middle term of negative 8, and the product was the last term of 12. So we think of all the numbers that when I multiply them together, I can get 12. So I've got 1 and 12, 2 and 6, 3 and 4. In order for the sum to be negative and the product to be positive, both numbers have to be negative numbers. And then what we're doing is we're combining or adding them together to see which one gives us a sum of negative 8, and that's the negative 2 and negative 6. So then I've got x minus 6 and x minus 2. This works because when I multiply this out, I get x times x, which is x squared, x times negative 2x, negative 6 times x, and negative 6 times 2. And then this gives me my negative 8x. So we're going to look at these three questions. Factor by inspection, so we're going to look at our sum and product chart for each of these. So if I look at the first one, I've got a sum of 13 and a product of 30. So I think of all the numbers that multiply to 30. I've got 1 and 30, 2 and 15, 3 and 10, and 5 and 6. The product is positive, the sum is positive, which means both of these numbers have to be positive. Add them together. The one that matches up is the 3 and 10. So I'd have x plus 3 and x plus 10. If I look at B, B is a little bit different because in B, my product is negative. So to get a negative product, it means that you have to multiply a positive and a negative. Product is still 30, so these numbers still add up, but one would be positive and one would be negative. So when I go to combine these, if I have a positive and a negative, I'm finding the difference between them. So the difference is 29, 13, 7, and 1. So 13 is the one that I want. To make it a negative 13, I make this a negative 15. So I get x minus 15 and x plus 2. Okay? And then in our final, oops, wrong one. Let's pick orange. In our final question, again, we have a product of 30. The sum is negative. The product is positive. So if the product is positive, again, the two numbers have to be both positive or negative. Because my sum is negative, they both have to be negative. So I'm finding the sum between them. And the sum that gives me 11 is the 6 and 5. But they would both be negative this time. So I would have x minus 5 and x minus 6. The next type of factoring that we did, I don't like this title. It was basically, it's an x squared minus c squared. So x squared minus c squared, this was called a, if you go in to explain how to factor this using a method of inspection. So if we did this using the sum and product chart, product is negative 16, the sum is 0. So I think of two numbers that when I multiply them together, I get a sum of, multiply them together, I get negative 16. Add them together, I get 0. So if I list off all of the factors of 16, this is what I get. 1 and 16, 2 and 8, and 4 and 4. In order to get a negative 16, one has to be positive, one has to be negative. So then I'm finding the difference between them, and the difference that gives me the 0 is the 4, and if I make it a negative 4. So this would be x minus 4 and x plus 4. So this is what's called a difference of squares. So in a difference of squares, first of all, it has to be a difference. It does not work if it's x plus or x squared plus something. The two terms have to be perfect squares. So x squared, x to the power of 4, x to the power of 6, those are perfect square variables, and then perfect square numbers, things like 4 and 9 and 16. So if we look at the examples on the next page, x squared minus 49, this is a difference of squares because it's a difference. This is a square number, and this is a square number, 49. So to factor a difference of squares, square root x squared, I get x. The square root of 49 is 7. One's positive, one's negative. So if you want to go through the next three, t squared minus 64, again, I get t and t. The square root of 64 is 8, so I get a negative 8 and a positive 8. With c, instead of having an x squared, I have a 25x squared. It still works. The square root of 25 is 5. Square root of x squared is x. Square root of 1 is 1. So I get 5x minus 1 and 5x plus 1. And then in D, if I have numbers in both terms, again, you're just square rooting. So the square root of 100 becomes 10x plus 9 and 10x minus 9. It doesn't matter if you put plus 9 first or minus 9 first. If you notice in 3 of my examples, I have the minus first and then the plus. That doesn't matter as long as one's positive and one's negative. The next type of factoring kind of relates to the first two in being able to factor out a greatest common factor first. So if we look at 2x squared minus 50, well, we've been kind of going over if it's got two terms, it's a difference of squares. But I can't square root 2 and I can't square root 50. But 2 and 50 have a common factor. They both have a 2 in common, so I can divide both terms by 2 and I get x squared minus 25, which is a difference of squares. So this x squared minus 25 gives me an x plus 5 and an x minus 5. So this is the note that's here, and it's an important note because it says when you factor a quadratic, always take out a common factor. Start with whether or not there's a common factor that you can take out of each term. So that's what we're going to do in class example number 3. So if you want to challenge yourself, you can pause, and then you can go through and try to take out the common factor, then check to see if you've got 2 terms, look for a difference of squares. If you have 3 terms, look for the inspection. So if we look at A, 5x squared minus 20, there's a 5 in common, so I factor the 5 out, and I'm left with x squared minus 4, which is a difference of squares, gives me x plus 2 and x minus 2, and that 5 has to stay out in front. It has to carry down with each step, because I should be able to always work from my answer back up to the question through multiplying with the distributive property. If I look at B, 2, 16, and 30 can all be divided by 2, so that's what I'm going to factor out. I get x squared plus 8x plus 15. So my sum and product chart, my sum is 8, my product is 15. If I think of numbers that multiply to 15, I get 1 and 15, and 3 and 5, and this is the one that gives me a sum of 8. So that gives me x plus 3 and x plus 5, and the 2 stays out in front. Now, C is tricky because when I look at C, 16 is a perfect square and 64 is a perfect square. So it can be tempting to factor or to do this and come up with 4x plus 8 and 4x minus 8, which is correct. But it's not simplified because in each of these I can take out a 4. So I would have to go through and take out a 4 and then combine the two 4s to give me 16 to get to this point. So if you need to pause so that you can write this down on the side, because I'm going to erase this and show you another way that you could get to this answer. Okay, so I'm going to erase this. If instead, if we're always making a practice to look for a common factor, 16 and 64 can both be divided by 16. Leaves me with x squared minus 4. This is the same as what I had above, x plus 2, x minus 2. So you'll still get the same answer if you carry through all the steps, and that's making sure that when you look at these binomial factors that they can't be factored again. If I look at D, I have negative 3x squared plus 6 plus 9. I look at the numbers 3, 6, and 9, and I think, yeah, I can divide everything by 3. This is a negative out in front of the x squared. If my x squared is negative, factor that negative out. So factor out a negative 3 rather than a positive 3. That gives me a positive x squared, a negative 2x, and a negative 3. So I look at my sum and product chart. Sum is negative 2, product is negative 3. So I think of numbers that multiply to 3. This is the only possibility, 1 and 3. To make this a negative 3 means 1 has to be positive, 1 has to be negative. In order to make this a negative 2, the 3 is what has to be negative. Negative 3 plus 1 is negative 2. So I get x plus 1 and x minus 3. Okay, and here are your practice questions, 1, A and C, 2, A and C, 3, A and C, 4, A and C, 5, A, C, E, and G, and 6, A, C, and E. Okay, so in the next section, we're going to look at a process necessary for factoring quadratic expressions of the form ax squared plus bx plus c, where the number in front of the x squared isn't a 1. Because everything, even when I factored out the GCF, I always end up with a 1x squared. So we need to be able to factor when we don't have a 1 out in front. So there's a couple of things to look at. First of all, we can have, instead of common factors just being a term, or like a 3 or an x, or maybe even a 3x, we can have binomials. So if we look at class example number 4, if you look at each term, this is a term, and this is a term. If I look at each of those terms, they have a common factor, and that's the x minus 9. The whole thing is common to each. So I can factor, meaning divide, x minus 9 from each term. If I factor x minus 9 divided by x minus 9, I get a 1 there, so it leaves me with just the 3x. X minus 9 divided by x minus 9 leaves me with negative 2. So I can repeat the process for the next 3. If you want, you can pause again and try to see if you can do these on your own. So if we look at B, 2x plus 1 is common, so that's what I'm going to factor out. Leaves me with a 5x plus 7. And you notice what I factored out, I put out in front. So if I look at C, 2x plus 1 is common to each. When I divide, I'm left with a 9x in the first term And in the second term, remember what I said up here. 2x plus 1 divided by 2x plus 1 is 1. So I have to put that plus 1. It's important. If I don't put the plus 1 in there, I'm changing the value of this equation. In D, 3 minus 2x is common to each, so I factor it out, and I'm left with 8 plus x. This is kind of written the reverse of how we usually see things. We usually see an x and then a number, and sometimes, a lot of times, it's okay to just leave it like this. If it's given to us in this ascending order, we can leave it in ascending order. The final type of factoring we're going to look at for this lesson is grouping. So grouping works when I have like 4 terms. Okay? What I can do is I can pair off, I can split up my 4 terms, and I can factor what's common into each, and then look to see what happens from that. So I'm just going to jump into class example number 5 and show you what this means and what this looks like. So I have 4 terms. I'm going to look at those 2 terms, x squared and 4x. The only thing they have in common, they both have an x variable. So I'm going to factor that x out. X squared divided by x leaves me with x. 4x divided by x leaves me with 4. Now I have the 6x and the 24. What can I divide both of them by? They're both divisible by 6. 6x divided by x, 6 is x. 24 divided by 6 is 4. Now, this resembles the questions that we did above, where I have a common factor, and then that leaves me with x plus 6. So I went from a question that had 4 individual terms to 2 terms, because the plus sign separates my terms, to really only having 1 term, because there's nothing separating these 2 factors. Okay, so if we repeat the process for B, 2x squared and 8x have a 2x in common, leaves me with an x minus 4. 3x minus 12 has a positive 3 in common, which also leaves me with an x minus 4. I can now factor out the x minus 4, leaving me with 2x plus 3. If we look at C, 8x squared minus 4a has a 4a in common. So that's what we would factor. So we can factor out a 4a, leaves me with a 2a and a minus 1. If I look at this term here, the 2a minus 1, it doesn't look like they have anything in common. And when you get a situation where, well, there's nothing in common, I can't take anything out, you can always take out a 1, a positive or a negative. So I can take out a positive 1. It doesn't change anything, but it just gives me a placeholder. So now I have 2a minus 1 as my common factor, leaving me with 4a plus 1 as a result. If we look at D, 6x squared and 9x have a 3x in common, leaves me with a 2x minus 3. D is a little bit different from the other ones in that this term here is negative. So 4x and 6 have a 2 in common, but this time I don't want to take out a positive 2, I want to make this a negative 2. So that when I go negative 4 divided by negative 2, I get a positive 2x, because I want it to really match up with this. 6 divided by negative 2 gives me a negative 3. So I'm trying to force this term to be like this one. So I get 2x minus 3 and 3x minus 2. So if I look at E, 6x squared and 8x have an 8x in common, leaves me with a 2x minus 1. And again, we've got this 2x plus 1 or negative 2x plus 1 that doesn't look like it has anything in common. But remember what I said above, I can always take a 1 out. But I want this to be a negative 1 because negative 2 divided by negative 1 gives me a positive 2x. Minus 1, so I get 2x minus 1 times 8x minus 1. So to add on to the questions from yesterday, we've got questions 8, A, C, and E, and then questions 10 to 15.